Welcome to the class once again. I'm your physics instructor. Wherever you're watching all over the world. Our topic today is motion under gravity. Before we start talking about motion under gravity, we'll remember that the basic law of gravity says that whatever goes up surely comes down. It will not be difficult for us to understand that this force that brings things or try to pull things down when they are thrown up, the forces are invincible. But the question is, do they exist? They do. The kind of force that brings body down when they are being thrown up or being influenced under the earth's surface, that force is called force of gravity. And when that force of gravity acts on a body, it tends to give the body an acceleration. And that acceleration is called acceleration due to gravity. You can say it's acceleration caused by gravity. You can say it's acceleration brought about by gravity. Now, that acceleration is normal. On Earth's surface, we already have an estimated value for that. On the Earth's surface, we have an estimated value for the force acceleration due to gravity as G on Earth is equal to 9.8 meter per second square, or approximately 10 meter per second square. So most time you see your teacher write it here, take G as equal to 9.8 meter per second square, or take G as 10 meter per second square. So it is the acceleration due to gravity. So when you want to measure gravity, you measure gravity on Earth with respect to what that gravity does to bodies on Earth. And what does it do to the bodies on Earth? It causes them to accelerate with an acceleration of 9.8 meter per second square or 10 meter per second square. Now, but on the moon, we also discover on the moon, within the limits of experimental errors, that gravity on moon too is about 1.67 meter per second square. So because of that, we can draw a relationship between the two of them within mathematical estimations, that gravity on moon is equals to gravity on Earth divided by 6. So sometimes you can have questions from your post-UME, from your IGCSE, relating gravity on moon and gravity on Earth. Gravity on moon, gravity on Earth. The relationship between them is that gravity on moon is 1/6 gravity on Earth, and gravity on Earth is 6 times gravity on moon. Thank you. Now, the existence of gravity, motion under gravity. Some years ago, though our forefathers in the black race, we understand that gravity existed, but we were not able to explain it, although we had our own tools, which was not put into records. But far out there in Europe, some persons used to believe that if you throw two objects from the same height, for example, a piece of iron and a carton, probably of different size, but we all know that the piece of iron will be heavier than the carton. So by the time you simultaneously throw them from the same height, some persons believe that the metal will hit the ground before the carton. Yes, under normal circumstances it should. But it was discovered that it is not true. And how was that discovered? There is a place they call the Leaning Tower of Pisa out there in Naples, in Italy. A man called Galileo Galilei, the legendary physicist, an astrologer, did an experiment. But the place where that experiment was done was different. That place had something unique. It was something like this. It's called the Leaning Tower of Pisa. Pisa. So, at the middle of the tower, it has a space, and that space it has no air resistance. There is no air resistance at this space. So it is a vacuum without air. So when you simultaneously throw a heavy object and a light object, the light object is being affected by air resistance. But for the heavy object, the air resistance on the heavy object will be negligible, meaning it has less effect on the heavy object, but more effect on the light object. So because of that, the light object will have to dazzle before it gets to the ground. Unlike the heavy object, it goes straight. So because of that, the heavy object lands before the light object. Now, so when Galileo got there, he simultaneously dropped two bodies, and those two bodies, one was heavy and one was light. And funny enough, he timed them and they landed at the same time. So he discovered that the reason why when you throw or drop two bodies simultaneously, heavy, light object, the reason is because why they land differently on normal space with air resistance is because of that air resistance that affects the light object. But when there is no air resistance, gravity acts on them equally. The gravity that acts on the heavy object is equal to the gravity that acts on the light object. So the two of them will land simultaneously at the same time without air resistance, or you use the word air resistance negligible. Good. Now, that is gravity. Now the question is, we are going to take out calculations that has to do with gravity. Because it is motion that is under gravity, then our equations of motion, which we treated in our previous classes, is going to come into play. Now let's take a look at this. When you throw a body upward, you observe something, that as the body is moving upward from the ground level, it goes and it finally comes down. Because whatever goes up surely comes down. When you throw this body up, you observe something, that the body, as it's moving upward, you throw it with an initial velocity, it's moving upward. As it's moving upward, something will happen to the body. The velocity at which it's moving upward will begin to reduce. Why? Because the body is moving against gravity. Now, when a body is moving against gravity, it shows that the body is against gravity. When something is against you, that thing is negative of you. So when a body is moving against gravity, the body is moving upward. That sign shows that it's moving upward. So the value of acceleration due to gravity is equal to, A is equals to minus G. Take note of that. Very important. Now, but something else is happening when that body is moving upward. Because as it's moving, his velocity is reducing. You have already shot the body with an initial velocity. It shows that initial velocity U has a value because it was shot with that initial velocity. But by the time he begins to climb, his velocity begins to reduce because it's against gravity. So the velocity is reducing. It will reduce to a certain point until it gets to this point, which is the maximum height. As it gets to that point, at that point, the value of his final velocity is equal to 0. So take note of this. When a body is moving upward, the value of V, the final velocity, is equal to 0. And when a body is moving upward, the acceleration due to gravity is negative. Now, what about if the body is coming down? When the body is moving down, another thing. Now, the body is falling from 0 down. As it's coming down, you observe that the value of U, where it's coming from, is 0. So initial velocity at this point becomes 0. But the value of G is no longer against gravity when it's falling. It's now under gravity. When you are against gravity, minus G. When you are under gravity. It's not falling under gravity. It's falling under the influence of gravity. It's no longer quarreling with gravity. So because of that, A is equals to plus G. So because of that, we can rewrite the equations of motion. We can write them as V is equals to U plus or minus GT. We can write the second as V squared is equals to U squared plus or minus 2GS. And the last one is S is equals to UT plus or minus half GT squared. So that is why sometimes when you're reading, you observe that you see some questions you are having the value of A here. Sometimes you're having the value of G. So from this your key view now, it's easy for you. Anytime you're answering question that has to do with velocity, motion, velocity that is under gravity, just remember this. Have this in your head as a framework. Immediately you have this, you don't have a problem. Remember, as the body moves upward, V is 0. As the body moves upward, the value of A is minus G. That is why it is either plus or minus G. Now when it's falling back, U is 0, and it's under gravity, A is positive. Now, we're going to take a question to support that. So from here, from our example, it said, on motion under gravity, it said, a ball is thrown vertically upwards with a velocity of 30 meters per second. This velocity is an initial velocity. It was thrown with a velocity of 30 meters per second. It was thrown. Good. Vertically upwards. It said calculate the time to reach maximum height. Now from it being thrown vertically upward, it shows that it is a motion that is under gravity. Good. It said the time to reach the ground again. That's the second question. We'll start with the first one. The time to reach maximum height. Very simple. This is the simplest part of it all. Calculation. Now, a ball is thrown vertically upward with a velocity of 30 meters. So you just pick it up. Your initial velocity is 30 meters per second. That is the value of U. You've taken that already. Now the next thing you are going to consider is that when this body is moving upwards, from my key view, the body is moving upward. What's the value of V? Oh, V must be 0 because it's against gravity. V surely will be equals to 0. So from here, after knowing that V is 0, you ask yourself, okay, good. Oh, we're given the value of G to be equals to 10 meters per second squared. Good. We talked about G earlier on. Now, from here, the time taken to reach maximum height. But this G, is it positive or negative? Is the body under gravity or against gravity? For the body to be thrown up, it shows that the body is against gravity. Is fighting against gravity. So at that point, the body, A, the value of A is equals to minus G. Good. Now after that, what do you have? We have find the time to reach maximum height. Now, we are looking for time to reach maximum height. We don't know that yet. So from the time, we can use which of these equations? We can have V is U plus AT. If you look at the three equations that was given in the equation of motion under gravity, you will discover that you have the value is A plus T. This is the original equation. But because it's under gravity, it becomes U plus or minus GT. So from here, this equation satisfies this all. So let's start replacing them. The value of V is 0. The value of U is 30. Oh, the value of G, is it plus or minus? It is minus, so we're going to have minus gt. And what are we looking for? If you move this gt from this expression now, the value of gt here is minus at the front. And when the minus sign crosses the equality sign, surely it's going to become positive. So if I move it across, I will now have something like this. gt is equal to 30. If I divide both sides by g, why will I divide both sides by g? Mathematically, you have to divide both sides by g. The reason is because for t to be free, you need to take g out. And the only way to do that is to divide it. And that is g off. So what is the value of t? That becomes 30 over g. What is the value of g again? Oh, we discovered g is 10. So we have 10. So from here, if 0 cancels 0, 3 divided by 1, that is equals to 3 seconds. That's the answer to the first question. Very simple. Good. Now, the next question, that's for question 1. Now the next question, class, is at the time to reach the ground again. The time to reach the ground again. What is the time to reach the ground again? At the maximum height. The time to reach the ground again, the body is thrown vertically upward. When it gets to a height, it comes back. The time to reach maximum height and return. When we get to motion under gravity with projectile, it becomes a different ball game. But now, it said the body was thrown vertically upward. So if it takes the body 3 seconds to move and get to this height, it will take the body another 3 seconds when it gets to that to fall back. After all, the ground level where the body was shot initially, the ground level is not going down. The ground level remains. So if you throw the body from the ground level, it gets to a certain height, it begins to fall back. Meaning, for figure 2, the body was thrown. It moves. It moves. It moves. And when it got to this place, it starts falling back again. It moves. It moves. It moves. And this is still the same ground level. It's short. It moves. It moves. It moves. It starts falling back again. It moves. It moves. It moves. It moves at the same ground level. The ground level is not changing. So if you take it 3 seconds to move from here to here, it will also take him 3 seconds to return back. Because it moves from here, 3 seconds to get there. As it's coming by, to take him 3 seconds to return back. So, therefore, what does that mean? Time to reach the ground again is equal to 2 times 3, which is equals to 6 seconds. Okay, from the second question now on motion under gravity. We've taken the first. I hope you understand that. Now, let's take another question that will explain the calculations better. Now, he said a man falls from the top of a house of height 50 meters. The first question we treated, there was nothing that has to do with height. There was no value given for height. But now we have height as 50 meters. It said calculate the time it takes to fall. G is 10 meters per second squared, as usual. Now, let's pick out the values. A man falls from the top of a house. If he's falling from the top of a house, is he under gravity or against gravity? Oh, he's under gravity because it's falling. So because of that, the value of A is equals to plus G. That's the first. He said, and what's the distance it takes? The height is 50 meters. And he said calculate the time it takes to fall. So because of that, if it takes that time, surely we have time not known, but we know that the value of g is positive. So what are we looking for? Time. So from here we have a to the d, but at this point we'll ask ourselves, as this body is falling down, does it have an initial velocity? No, it has no initial velocity, it only has a final velocity. And our question has nothing to do with final velocity. But our initial velocity, surely we know is equals to 0. And that shows that it's under gravity. Remember your key view that I gave? If you check it carefully, you'll notice that as a body is falling down, the value of u is equals to 0. Now, from here, we can pick our values. Tell you, from the three equations we're given, v is u plus or minus gt. You have v squared is equals to u squared plus or minus 2gs, and the last one, s is ut plus or minus half gt squared. Now from there, from these three equations, which of them will satisfy this? How do you do that? It's simple. I can have v is this and that, but there is no value of s here. If I have to use the second equation, there is no value of t here. But the only equation that satisfies it is this particular equation, which has the value of s, has the value of u, has the value of g, and has the value of t. So because of that, I will say using s is equals to ut plus or minus half gt squared. So from here, the value of s is 50. So you have your u, which is 0, and you have your time, not known yet. Oh, the value of g, is it plus or minus? It is plus. So because of that, we'll have plus half g t squared. So because of that, I will have 50 is equal to half g t squared. Now, this will disappear because 0 times anything will give me 0. So because of that, what's my next value? So I'll have 50 is equal to gt squared over 2. It's still the same thing as half gt squared. But funny enough, what's the value of g? The value of g is 10. So I will have 50 is equal to 10 t squared over 2. Now let's deal with mathematics. Because this equality sign exists here in mathematics come to play. How? 0 will cancel 0. What will be left here is 5. It's called speed dies in mathematics. Although those who introduce mathematics to us, they call it computation. So if you have this, cancel this. So what do I have here? 5 divided by 1, 2. 2, now from here you can do what you call your cross multiplication. 2 times 5, that is 10. Is equals to 1 times this, that will be t squared. So that your value is 50 gt squared, that, back 10 equals to t squared, then t square root of 10. And what's the square root of 10? Good. Square root of 10 is 3 points. You should have 1, and you should have 6. All in seconds. Thank you very much. And you can attempt any question as far as motion under gravity, but always remember your key view. When the body is going up, g is minus, v is 0. When the body is coming down, u is 0, and g is positive. With that, you don't have any problem with questions that has to do with motion under gravity. Thank you very much.